Welcome back, and now we will be looking at what we are calling the percentage error. So we'll be looking at percentage error. And what do we mean when we are talking of percentage error? So some error or uncertainty always exists in any measurement. So the skill of the measurer places limits to the reliability of the results. So the skill. Here the main problem is the skill. So the skill of the measurer places limits on the reliability of results. So maybe the measurer is not very well skilled in using the instrument for measuring. So the conditions of measurement also affect the outcome. So if you see here, what we have here is around 6.123, then 3. Maybe 0.5 or something. But someone may write this as 6.4 or rather 6.3. So because of these inconsistencies, or these inconsistencies are what we are calling errors in measurement. So the conditions of measurement also affects the outcome. So the measuring instruments can place limitation on precision. Some balances can be read more precisely than others. So some are, like the digital ones, are more precise than the manual ones. So the same is true of rulers, graduated cylinders, and other measuring devices. So when you use a properly calibrated measuring device, you can be almost certain of a particular number of digits in a reading. For example, you can tell that the nail is maybe, like in this figure, that it is definitely between 6.3 and 6.4. So the definite thing is that it is in between here. So we would expect the measurement to be here, in between. So if looking more closely, you can see that the value is halfway between the two. So however, if it's hard to tell whether the value should be read as either 6.35, if it's hard for you to read it as 6.35, or 6.36 centimeters. So if we take centimeters, then what we are saying here is the 100th place is thus somewhat uncertain. So simply leaving it out would be misleading. Simply leaving out simply leaving out some measurements. Would be misleading. Maybe what you are leaving out could turn out to be the reason of change of some result, and maybe you would seem to have contributed to failure of an experiment. So because you do not have some indications of the values likely range, so therefore you would estimate the value to the final questionable digit, perhaps reporting the length of the nail as either 6.36 centimeters. So instead of having those doubts, you might include a plus or a minus value to express the range. So you might, for example, you might include a plus or a minus. So you can include a plus or a minus value to express the range, to express the range. For example, you would have 6.36 centimeters plus or minus 0.01 centimeter. So instead of just assuming that it's either 6.3 or 6.4, it's better if you show it using this scale of error measurement. The next thing that we will look at is significant figures are those measured precisely plus one estimated digit. Significant figures are those. So when we are talking about significant figures, they are those that are measured precisely plus one estimated digit. So if we go back here, this would be the precise ones, and with the error, this can give us the estimated digit. So in science, measured values are reported in terms of significant figures. In science, measured values are reported in terms of significant figures. Significant figures is in a measurement. Significant figures in a measurement consists of all the digits, consists of all the digits known with certainty with certainty plus one final digit. One final digit. Which is somewhat uncertain or is estimated. Which is somewhat uncertain or is estimated. Or is estimated. So, for example, in the reported nail length of 6.36, for example, in the reported nail we had nail length, in the reported nail length we had 6.36 centimeters as discussed earlier. So the last digit 6 is uncertain. This digit here. The last digit 6 is uncertain. Which means we have no certainty about it. Is uncertain. So all the digits, including the uncertain one, are significant figures. All the digits, including the uncertain ones, are what we call the significant figures. So all the digits including the uncertain one, are significant. They are significant, however. So all of them are significant. So all contain information and are included in the reported value. Thus, the term significant does not mean certain. In other correctly reported measured value, the final digit is significant but not certain. So, insignificant figures are never reported. Insignificant figures are never reported. And there is no need of reporting them since they are insignificant. So as a chemist student, you will need to use and recognize significant figures when you work with measured quantities and report your results, and when you evaluate measurements reported by others. Determining the number of significant figures. So how do you determine the number of significant figures? That is what we are going to discuss next. So when you look at a measured quantity, you need to determine which digits are significant. That process is very easy if the number has no zeros. So it's very easy if the number has no zeros. If the number has no zeros. So if it has no zeros, it's very easy because all the digits shown are significant. For example, because all the digits shown are significant. All the digits shown are significant. So let's look at the example here. For example, 3.95 and the number 3.95, all the three digits are significant. All the three digits are significant. So all the three are significant. So the significance of zeros in a number depends on their location. So the next point to note is that the significance of zeros in a number, the significance of zeros in a number depends on their locations. Depends on their locations. So where they are located will determine their significance. So you need to learn and follow several rules involving zeros. After you have studied the rules, then you can use them to answer sample questions. So let's go and look at these rules before we embark on attempting to answer some sample questions. So the table here gives the highlights on rules for determining significant zeros. As I told you, if it has no zeros, it has no problem. But if it has zeros, then the significant factors or numbers will depend on the location of the zero. So zero appearing between non-zero digits are significant. So if the zero is appearing between non-zero digits, so this is not zero, this is not zero, and we have zeros here in between, so such zeros appearing between non-zero digits are significant, and we will count them. So let's see how many we have here. So 1, 2, 3, 4, 5. So we have 5 significant figures here in this number. Here 1, 2, 3. We have 3 significant figures in this number. Second one, the second one, zeros. The second one, zeros appearing in front of all non-zero digits are not significant. So if the zeros are appearing in front of all the non-zero digits, then they are insignificant. So let's look at example here. So all these zeros here that are appearing in front of non-zero digits are insignificant. So how many we will have here? 1, 2, 3, 4, 5. So we have 5 significant figures, and here we only have 1 significant figures. Rule number 3. Rule number 3. Zeros at the end of a number and to the right of the decimal point are significant. So if you are having a number, then you have a decimal, then you have zeros. These zeros will be significant. So here how many we have? 1, 2, 3, 4. So we have 4 significant figures. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of them are 10 significant figures. So if they come in between, they are significant. If they come before, they are insignificant. If they come after, but after a decimal, they are significant. Let's look at the last rule here. The last rule, zeros at the end of a number, zeros at the end of a number, but to the left of a decimal. But to the left of a decimal point may or may not be significant. So if a zero, so we are saying here, if a zero has not been measured or estimated, but is just a placeholder, it is not significant. A decimal point placed after zeros indicates that they are significant. So a decimal point placed after zeros indicate that they are significant. So we are having here 2,000 mirrors may contain from 1 to 4 significant figures depending on how many zeros are placeholders. So for measurements given in this text that we are using to study, assume that 2,000 mirrors has 1 significant figure, because these ones are insignificant. The reason being that they came after the non-zero number and without a decimal. If they have a decimal, like in this case here, they contain 4 significant figures indicated by the presence of the decimal, then we say they have 4 significant figures because of the decimal. So we should keep this in mind, and we will be using this every time we are calculating or trying to find the measure of significant figures. So we'll stop here, and in the next video we will be doing some sample examples on significant figures.